Hi, I'm Hojjat, and I'll be talking about KSQL, open source streaming SQL engine on Apache Kafka. Hello, everyone. I'm very excited to be here to talk about KSQL, which is a streaming language on top of Apache Kafka. And I'm going to show you how to do real-time ETL using KSQL to load the real-time results to Scylla or Cassandra in an example. A little bit about me. I'm a software engineer at Confluent, and I started the KSQL project last year at Confluent. We released the project in Kafka Summit in August this year, and we got overwhelming excitement from the community, so I'm very excited to talk about it today for you, and hopefully you will be also interested, and you're going to go and try it. It's an open source project. I have the links at the end of the project, the presentation, but of course you can Google it and find it. Previously, I worked in a couple of companies, mostly on big data projects related to Hadoop and Spark. And I have a PhD in computer science from UC Irvine. My PhD was about data management, publish subscribe systems, and streaming app systems. OK, let's dive into the presentation. So ETL, you have exposed to it. I guess most of you know what we mean: extract, transform, and load. And most of the ETL process so far has been done in a batch way. For instance, every night you have an ETL job that reads from a source and does transformations and load it to another source. But we are going towards the streaming world where you have to have the results as soon as possible. You can't wait a day or you can't wait an hour to run that batch job every time. So as you may have known, now real-time ETL or streaming ETL becoming a fashionable thing, and a lot of people are moving towards this world. So this is a very simple demonstration of, at the end of the presentation, we want to have some pipeline like this, meaning that we are going to read data from a source, bring it to the Kafka cluster, do some transformation, and load the data to another system, which the destination system, surprisingly, it's going to be Scylla in this example, but it can be any other systems that you can load data from Kafka to. All right. Before that, let me talk a little bit about the streaming platform and what we mean by the term streaming platform. In any organization, you have many systems, especially when you're dealing with huge amounts of data. You have a lot of data sources, a lot of applications generating data, and a lot of applications consuming this data. And if you don't have a structured way of doing this, it can easily turn into a mess. You may have an application and multiple applications are consuming the data that's generated by that application, and you can see that you may end up with end-to-end matches of conversions. So the idea is that if you, instead of having this mesh of conversions and production and consumption of data, use something like this. Put a streaming platform in the heart of your company and have all of the systems in your company to consume and produce data from this streaming platform. This provides a couple of very interesting properties for your system. One, it decouples the producers and consumers of the data. So you have, let's say, a weblog, and you have an analytics system that you want to analyze your visitors to the website. And there's no need that they exactly connect and consume data from each other. Producer can put it in the streaming platform, and the consumer can just consume it from there. That decoupling provides significant advantage compared to a tightly coupled system. Another important advantage of having such streaming platform is asynchronous communication, meaning that when you produce data, the consumer should not be there to consume it. Anytime consumer decides to consume, they can just connect to your platform, streaming platform, and consume the data. That decoupling also significantly simplifies your architecture. So having said that, hopefully I convinced you that this could be a very interesting approach to managing your data. Let's see what we propose. Of course, I'm from Confluent, and definitely we think that the Kafka should be the streaming platform for your company. And in Kafka, just a quick overview, you have a set of topics that are partitioned, and you can produce data to a topic, meaning that you're writing to the topic, and you have consumers that consume that data from that topic. And to connect the different systems to the Kafka cluster, we have a set of connectors in Kafka that provides this connection for you. For instance, if you have data in Kafka and you want to move it to Scylla or Cassandra, we have a connector for that you can easily connect to your Kafka cluster, and move your data to your other systems. So assuming that this is going to be the future of data platforms in companies, let's see how we can do ETL. So to do ETL, we are going to consume from data that's produced outside the system, bring it to Kafka, do a little bit of processing there, and move it back to the external system or destination system. And for this, as I mentioned, we have connectors to connect Kafka to different systems. So you're going to have Kafka, and you're going to have a set of connect workers that you can delegate this kind of moving data in and out of Kafka to different systems, to the connect workers. We have quite a lot of connectors. As you know, we have had Kafka for several years, and during these several years, not only it has been in production and battle-hardened, but also there's a lot of connectors that connects Kafka to different systems that you can bring data from those systems inside Kafka, and can move data from Kafka to all of those systems. And we have Cassandra and Scylla also among these systems that can read and write from Kafka. So this would be the first step if you want to do continuous real-time ETL. Let's say you're reading from some source, you're bringing data to Kafka, and you're writing it to another source. But just moving data may not be enough for you. You may want to do a little bit of computing too. So for that, Kafka Connects provide a mechanism called single message transform. In single message transform, every message which you are reading from outside system, before writing it to the Kafka cluster, you can do some processing. So as you see in the input side, you have the Kafka Connect reading from outside system. You can do different processing, like you can drop some sensitive information, you can set some partitioning keys, you can store lineage, you can do a lot of like single message transformation. As the name shows, here you are dealing only with one message. There's no notion of like doing transformation on the set of messages. And similarly, when you're writing the messages from Kafka through Connect to outside system, you can do some transformation. For instance, we can redirect the output to different systems or different indices, or you can convert the type, and this kind of simple transformation. But these are very simple transformations. Usually, it's not enough for your application to just do these simple transformation. So we need joins, we may need aggregations, we need filtering, we need like custom computations that you can specify in UDFs or UDAFs. So to address this need, we developed KSQL. So this is an open source streaming platform that you can actually write your streaming logic in CQL. And right now it's in the developer preview, and we are hoping that by end of this quarter or beginning of next quarter, we have it production ready. And again, as I mentioned, this is open source, Apache 2 license, so definitely go to GitHub repo and try it out. You're going to be amazed. All right, so what KSQL provides for us? So it enables the stream processing with zero coding. A lot of open source projects that we have, they do have some sort of SQL support in streaming. In the batch, you're not talking about the batch world. In streaming, you have some sort of like SQL in open source systems that we have for streaming, but in most of those, you'd need to embed this SQL inside your Scala or Java code. So definitely, there is a minimum need for using any programming language. Here, we aim to just get rid of any programming. You will be able to write your stream processing logic in SQL-like language, and that's it. You don't need to learn any other language. And we think that this is the simplest way to do real-time processing, and assuming that you are using Kafka, which a large majority of the systems are using Kafka. This is powered by Kafka, meaning that it's stable, scalable, and it's fault tolerant, and it's battle-hardened. So the major part of the processing depends on Kafka. So Kafka being a reliable system and battle-hardened system, you have that reliability coming from Kafka here. And one very important characteristic of KSQL is that you do not need an extra cluster. So if you use any other system, you need your Kafka cluster, and you need another stream processing cluster, then you need your application. So imagine one more moving part in your system, one more processing cluster in your system, and that is going to be much more expensive to tune, maintain, make sure everything is good. But getting rid of that middleman and having everything inside your application KSQL significantly simplifies deployment and maintenance of real-time applications, meaning that these applications are going to be continuous applications. You are going to run this for months and unlimited time, right? And you need to make sure that it provides that simplicity for you. In case of failure, in case of problems that happens, you can actually maintain this system in a robust way. So KSQL being implemented on top of Kafka and Kafka Streams provides that simplicity and scalability for you. Very simple example. So as I said, you just need to know SQL, nothing else. So here, imagine you have a stream of login attempts that come into your system. Let's say you say in every 5 seconds, if the login attempts count is more than 3 times, we consider that as a possible fraud or malicious user. So you can just write something like this and run it in your application, and you're done. You will be notified. The results are going to be written in a topic that you can use notification from that topic. So let's consider a couple of basic concepts that we have in KSQL. In KSQL, we have a notion of stream and table. Stream are the independent messages that you have in Kafka topics. Every message is an independent message, and there's no relation between 2 messages in the stream case. The way that you can interpret a topic is, in the case of a stream, is that you just process or you just consider every message independently. But there's another way of interpreting messages in a Kafka topic, and it is interpreting as a change log for a table. So in this case, every message that you get in Kafka, you have key and value for every message. Every message that you get, it's not independent. If you have the same key before, this message actually is going to be update for that key, meaning that it nullifies the previous one. This is the latest value. So as you see, the messages are not independent of each other. Messages are just updates. You are looking at it as a changelog for a table. So there are 2 ways to interpret topics in KSQL. We can interpret them as stream, and we can interpret them as table. And these 2 concepts are going to be used in our queries. When you are just doing simple filtering of a stream, you're going to create another stream. But when you are doing some count, you are doing a table because you are keeping that count key and you're updating the value, right? So you're going to interpret it as a table. KSQL provides a lot of features, and we are going to have much more. Right now, we have stream-to-table joins, we have aggregate functions, we have UDF support, we have complex expressions, and we have JSON and delimited format supported, and we are also having Avro very soon. So it's a very active project, as I mentioned earlier, and we are moving very fast to expand the features that are available. So now that we have the basics of the KSQL, one more important concept, window aggregation. In the streaming world, in order to do aggregation, usually you want to have a window to perform this aggregation on that window. KSQL provides 3 types of window currently, and we are going to hopefully add more. But the simple ones that we have right now is tumbling window. It's a fixed size, non-overlapping, gapless window. For instance, in this case, you are having a window for every minute. So it's going to be 1 minute and the next minute and so forth. We're also supporting hopping window. In a hopping window, it's kind of something similar to sliding window for you, meaning that you're going to have a window and you're going to specify advance of that window. As you see in this case, you can easily describe these in your query language. Window hopping, size is 20, advanced by 5 seconds. And finally, this is a much more important window in a lot of applications. We have session window support. By session window, it's a variable size window, meaning that, for instance, when you define your session, you say that, for instance, if nothing happens in next 20 seconds, the window ends. So this is more like defining the gap between windows instead of size of the windows. In this case, for instance, you say, give me the count of the bytes for every IP for sessions that don't have a gap of 20 seconds. So meaning that your window is going to, if you have any updates during the 20 seconds, your window is going to grow until you have more than 20 seconds of silence, then the window ends and new window starts. All right. So now that I gave you a little bit of quick overview of what KSQL is, what it provides, let's look at an example. In this example, we assume that we have data, web log is coming from outside system. Using the connect, we load it into Kafka. Inside Kafka, we do some transformations, and then we load it into Scylla or Cassandra to have real-time tables that are being updated by KSQL. So anytime you look at your Scylla table, you're going to see the latest values in real time. So this example is very simple, but of course you can apply it to a lot of different contexts. Simple web analytics pipeline. So here we have two streams. One stream is the page view. And every time your user clicks on a page, you're going to have a page ID, user ID, and the time that the user clicks on that page. And we have a user table. We load that table into the topic in Kafka. And every time user updates any of characteristics, we are going to add another message to that topic. But KSQL is going to only keep the latest values for that table. So meaning that if you have a user topic, when it is interpreted into the table, you're going to have a table in your application that reflects the latest values, similar to normal tables that you have in databases. Let's say we want to create two materialized views and store them in Scylla or Cassandra. We want to have a count for every region, how many visits we had from every region, and we want to also see demography of the region, male and female visitors for the website from different region. So the first step that we are going to do, we are going to, similar to any database system or any relational or SQL system, we're going to have DDL statements. In DDL statements, we're going to first say that, OK, I have a stream called page view, and this page view has these columns and these types. We also add extra information to make sure that KSQL knows which topic in Kafka it needs to read and what is the format of that topic. Then we have a user table. As I mentioned, both of them are topics in Kafka, but the way that you interpret them, you define it as a stream or table. In the case of user, it's going to be a table because we just need the latest values of the table. And similar to the normal create table statement in the databases, we can just write a create table user with the columns and then detailed information about which topic in Kafka and what format. Now that we have those two streams and tables, we can start doing stream processing. The first thing that I'm going to do is going to be a join between the page view and users, so to enrich my page view stream. So I'm going to create a new stream called the join page views. And I'm going to select user ID and page ID, region ID, and gender from the page view and join it with the user. And that's the join criteria. Very simple. As you see, you can literally write simple SQL-like code, and you're done. And then I can use the output of this stream and do a count. For every region, I want to count the number of visitors, right? So I'm going to say region visitor count, create a table. Here, I'm counting, so it's going to be an updating table. And as you see, I'm just selecting the column that I want to count based on and the count. And I'm using the result of the previous statement. And I'm going to use a tumbling window for every 30 seconds and group by region ID. And that's it. You are going to have a new topic in Kafka, which is going to be updated every time you have a new visitor. Let's consider the second application or query. In the example, which we are going to count the number of visitors for every region based on their gender too. So meaning that how many male from this region and how many female from this region in every 30 seconds visit my website. And I'm going to calculate it with, again, simple line of SQL code, and it's going to be, the result is going to be in the Kafka topic. Now that you have the results in the Kafka topic, easily you can use connect and move that result anywhere you can use. For instance, here you can have updated, real-time updated Scylla or Cassandra table that always has the latest counts for every window and every region, for instance. So easily you can just implement this pipeline with multiple SQL statements. So KSQL is part of the Confluent open source platform. As I mentioned, Confluent is providing Kafka. The creators of Kafka actually are our founders. And as you see, in addition to Kafka, we have a lot of other extra systems on the Kafka that you can use. We have open source platform that you can easily download and use it. It's Apache 2. And we also have extra enterprise application that comes on top of the Kafka and helps you to manage and run your Kafka smoothly. And definitely, as I mentioned, using KSQL in the Confluent platform is going to be much, much easier than using it independently with your normal Kafka. All right. Having said that, a little bit of marketing for our next summit. We have a Kafka Summit in London next year. And of course, after that, we are going to have a Kafka Summit in San Francisco. Keep the date. And by saying that, keep the questions. I'm just going to show you a very interesting demo on how to use KSQL. Can we switch to the laptop? All right. So this is one way of running KSQL. This is the simple terminal. I have two data generators. Let's see. I'm going to create a page view similar to the one that I created, and a user. So as you see, I'm adding data to the topic. So here, I can just create a stream page view. I can say show streams. I can say select star from, let's say, page views. And as you see, this is a continuous query. So you're going to see the results as they're being published to the Kafka results. And if you want to stop it, just Control-C. And then you can actually do, let's say, describe page view. You can see what columns we have. And you can say select star from page view, where, let's say, user ID, or let's say page ID. Or yeah, user ID equals to, let's grab one of these user ID, user tree. So as you see, as user tree visits the website, you're going to get the results. And of course, as I showed you earlier, you're going to have much more complex queries, joins, aggregates, different UDFs that we have so far. And all of them, you're just going to be able to just write streaming queries with no code, with no IDE, just from here. And of course, if you want to run it in a production, there are different execution modes that you can go and find out in our documentation. All right. By saying that, I guess I hope that you enjoyed the talk.